Welcome, my friends. In this video, I'm going to be discussing my fourth Google Sheets lab, which relates to probability. And as is always the case, if you'd like to follow along with this file, you can access the file in the description of this video. Once you have it open, you can go to File and make a copy, and then you can change the name to whatever you'd like to, maybe your first and last name, and then the name of the Google Sheets lab, and then you can go ahead and make a copy, and then it should allow you to edit this file. So the file we have here is relating to two rolls of a six-sided die. So we have the first roll of a six-sided die and we have the second roll of the six-sided die. And inside this table here, we're going to want to calculate the sum of the first and the second rolls. And then in addition to that, we're going to simulate rolling 1,000 six-sided dice, basically a first roll and a second roll, and then we're going to sum those up. We're going to list in this table all the possible values for the sum of two dice, so we could have anywhere from 2 to 12. Those numbers will go in here. We're going to count how many ways there are to roll those numbers based on the table that we will have created over there. We're going to calculate the theoretical probability by taking each of those values and dividing by 36, which is the total number of values, different values you can have for two rolls of the die. Or different ways you can do that. And then we'll calculate the relative frequency probability based on our simulation to compare that to the true theoretical probability and see how close we are. So let's first start off with completing this table here. So this table, really what we want to do is we just want to add up the numbers from the two rolls of the die. So if I had a 1 and a 1, I would want this to add to 2. Or if I had a 2 on the first roll and a 1 on the second roll, I would want that to add to 3. But instead of typing all these in, I'm going to use this as a way to explain what is called mixed references in Google Sheets. So you're probably familiar with relative and absolute references. A relative reference meaning a reference that is going to change as you drag a formula, and an absolute reference is a reference that is going to stay the same when you drag a formula. But basically here we need a little bit of both. We need what is called a mixed reference for these cells. What I mean by that is we always are going to want a value in column B for the first row, and we're always going to want a value in row 2 for the second row. But we want the values in column B to always stay the same when I'm referencing column B. But if I'm dragging up and down, I actually want the rows to change. I want this to change. If I code something here and I drag it down, I want this 1 to change to a 2, but I want this 1 to stay the same. Or if I drag this to the right, I want this 1 to stay the same, but I want this 2. This one actually to change to a 2. Okay, so hopefully you kind of see the idea here. We need it kind of like a partial absolute reference and partial relative reference. That's what we're going to call a mixed reference. And maybe the easiest way to show you this here is just to actually go ahead and do it. So I'm going to type equal here to start my formula. I'm going to want to add B1 to C1, but I'm going to want to modify these references so that they are mixed references. And the way you can do that is if you go right after the B3 here and I start pressing F4, when I press F4 once, it's going to create an absolute reference, meaning it would always reference that cell, but that's not what we want. If I press F4 again, it's going to create a mixed reference where basically the row 3 is absolute and the column B is relative. And that's not what we want here. We want column B to be absolute. We want column B to always be referenced. So we want to press F4 one more time, and we're going to get the $sign on the B, but not the 3. So what that means is B will always be referenced. So if I drag this formula to the right, we're still always going to reference column B. But if I drag this down, then this row 3 would change to row 4 and then reference 2, 3, 4, 5, and 6. So that's exactly what we want here. Now as for C2, I want this to be absolute in the second row. So I'm going to press F4, I think, twice here. Oops. So I'm going to press F4 twice, and I'm going to be absolute in the rows, but I'm not going to be absolute in the columns. So I'll have the mixed reference kind of in the opposite way here. So this says if I was to drag this formula down, the row 2 is going to stay the same. So when I drag down, I'm always going to be referencing this 1. But if I drag to the left or to the right, then column C is going to be flexible. Column C is going to change either to the left or to the right because we don't have the $signs on that one. Now if I press enter, I can either accept the autofill, or I can click here, click the fill handle and drag down, and I can click this fill handle and drag to the right, and then there you go. It has calculated the sum for all of those rolls. So maybe you could have done this without too much issue with a 6-sided die, but later, if you're going to do the practice exercise, you'll have to do this with a 10-sided die. It'll be a little bit more work to do manually. So using the mixed references here can definitely be helpful. Now let's just verify some of these numbers to make sure they're calculating correctly. 1 plus 1 is indeed 2, or 1 plus 2 is 3, or 5 plus 3 is 8. So it does appear that it is calculating those sums correctly. Let's go ahead over here and let's complete our dice rolling simulation now. So on our we're going to be using a function called randbetween to do this. So the function, if we type equals randbetween and open parentheses there, it's going to ask us for a low and a high value, and it's going to return a random number between your low and your high value. So if I put 1 comma 6, it's going to give me a random number between 1 and 6. Turns out in that case I got a 6. And anytime you modify anything in Google Sheets, it's actually going to update that formula. So if I just type something into any other cell, that formula is going to change. So anytime I start typing, that is going to change. So it kind of recalculates that random number every time you modify anything in Google Sheets. Now, we want to do a simulation of 1,000 rolls of the die. So we are going to drag this down 1,000 rows. But it turns out, if I go over here and I drag all the way down, I think this is right outside your screen, but I'm dragging my kind of option over here to be able to drag all the way down. You only get 1,001 rows on default. So I'm going to add 1,000 more rows first of all, just to make sure I have enough to fit 1,000 rolls of the die. And I'm going to make sure I have this cell selected, and I'm going to scroll down again. And note that was in row 3. So actually, if I go to row 1002, and I hold down Shift, so I'm holding down Shift right now, and I click on J1002. Now I'm holding down, I let go of Shift, and now I'm holding down Control, and I'm going to press Enter. Control and Enter, and that is going to drag that formula down all the way. Now, alternatively, I guess you could have clicked on the very first one and you could have dragged down manually 1,000 rows, but that takes a little bit of time. Instead, I selected the very first one. I scrolled down to the bottom here to 1002. I held down Shift, I clicked, I let go of Shift, I pressed Control and Enter, and that copied that formula down. And now we also want to have this formula in column K for the second roll of the die, so I'm going to drag that one to the right. I'm going to drag that one to the right. Let's do that. And that is going to fill that formula into column K as well. So now I have 2 rolls of the die. I'm going to sum those 2 rolls by using another function here. So I'm going to do equals. I'm going to take the 5, and I'm going to add, and then I'm going to add the whatever this number is. I can't really see it, but the value for roll 2. So I'm just using the arrow keys to arrow over to those. You could also press equals, and you could just click on them. So you can either click, or what I like to do in many cases, I just use the arrow keys and I can arrow to whatever cell that I would like to have. I'm going to press Enter, and that's going to give me a sum for the first one. Looks like it's 11. I'm going to accept the autofill to fill that all the way down, and then notice that once again these are kind of updating every time anything changes in Google Sheets. So maybe I don't want this to modify. Every time I type anything, these are going to change, but maybe I would like to make this static. I would like to make it so that these random functions are not calculating every time I modify a cell in Google Sheets. Well, one way to do that would be to simply copy and paste the values here. So right now there's a difference between the displayed value of the cell and the back end of the cell. So the back end of the cell is the random between function, but the displayed value is a 3. So one way to change this is to make the back end of the cell match the same value as what is being displayed. And the way we can do that is by copying and pasting values. And the way to copy and paste the values would be to first highlight columns basically J and K. So I'm going to click on this cell right here for K1, or I guess it's K3, which is resulting to the first dice roll. And then I'm going to hold down Shift and Control, so Shift and Control at the same time, and then press the down arrow, and I'm going to get to the bottom of the list. And then I'm going to hold down just Shift. I guess Control would work as well, but just Shift and then arrow once to the left, and that's going to highlight all of column J as well. And I'm going to scroll up to the top. I'm going to either do Control C, or I could right click and copy. I just did Control C there, and then I'm going to right click. You could have done copy there, and then I'm going to either I could go to Paste Special, and I'm going to either paste values only, or I could do Control Shift V. And when I do that, it's going to paste just the values. So now you can see the back end of the cell is a 3, as well as kind of the displayed value. So now we no longer have those random between functions in there, and this is just giving us those random numbers from 1 through 1000. So now this will not update every time we press Enter or change anything in the Google Sheets file. Let's scroll to the right and let's do some probability calculations. So first of all, the sum of the rolls could be anywhere from 2 through 12, right? We could have a sum of 2 dice, sum anywhere from 2 as the smallest value or all the way up to 12 as the largest value if we rolled 2 sixes. So that's what I'm going to type into this first column here. I'm going to type in a 2 and a 3 as the very first two. I'm going to highlight those and drag those down so that will complete the pattern. Now we want to know how many ways there are to roll each of those. Now, you could count those up here, and you could say, okay, there's one way to roll a 2, there's 2 ways to roll a 3, and maybe you can kind of see the pattern of the number of ways. But in general, it's usually a better idea to kind of use formulas to represent this stuff, especially if you had a more complicated example than this one. So I'm going to use a formula here. I'm going to use a COUNTIF function. And the COUNTIF function says, which range of values would you like to count? So I'm going to highlight that range right here. Let me get back in here. Somehow that messed up there. I want to highlight these ones, and I want to make that an absolute reference because I'm going to end up dragging this formula down, and I want it to always reference this little table here. So I'm going to press F4 to make that an absolute reference. I'm going to press a comma to move to the criterion argument, and the criteria is I want to count the values only if they are 2s. So I'm going to click on this value here, which is the 2. It's kind of hidden right here, but it is the 2, the sum of the roll being a 2. I'm going to close parentheses, press enter, and it is going to count that for me. It's going to suggest an autofill. Let's accept that. And that is going to count the number of 2s, 3s, 4s, 5s, all the way through 12s. So now we have all those numbers, and if I highlight all the way through here, you can see that it sums to 36, which is also the total number of values in this table here. There's 36 different ways to roll 2 dice, which is the 6 times 6. Now let's go ahead and calculate our theoretical probability. So we can calculate the theoretical probability by taking the number of ways to roll that value, which in this case is 003, and divide by either 36, or I can do a sum of all of these values. And these values are going to all sum to 36. I can do an absolute reference on that to make sure I'm referencing that every time. Press enter, accept the autofill, and that's going to give me the theoretical probabilities. Now I might want to change those to percent, so if I highlight those and click on the percent, that's going to change those to percentages rounded to 2 decimal places. So we can see here that the most common roll is a roll of 7, which happens about 16.67% of the time. That is 7 out of 36. The least common is either a 12 or a 2, which only happens just under 3% of the time. Now we would like to know how close is this to our dice rolling simulation? So we just simulated 1,000 rolls of the die. How close was our simulation to these actual true theoretical probabilities? Well, let's figure that out by doing another COUNTIF function here. So now we want to count this range here, the sum of the rolls. So I'm going to hold down Control, Shift, and down arrow to get to the bottom of this list. I'm going to press F4 to make that an absolute reference there. I'm going to scroll back up to the top. I'm going to press comma, and I want to count the sum of the rolls, and I only want to count them if it sums to 2. And I'm going to close parentheses, and I want to divide that by the total number of rolls that I did, and I did 1,000 rolls. I could do a count function to count all of these, but I know there's 1,000, so I'm just going to go ahead and type in 1,000 here, and that's going to give me 0.016. I can either accept the automatic fill, or I can double-click the fill handle here to get the rest of those. I'm going to highlight those as well, and I'm going to change those to percents. And you can see how close or how far away I was for each one. So it looks like I got a little bit less 2s than I would expect. I only got 1.6%, or that'd be 16 2s, when I should have gotten 2.78%, or about 27 to 28. I only got 5.1% 3s. I should have gotten 5.56. So you can see I'm under on a few of these. I was way over on my 7s. I got 18.6% 7s. I should have gotten 16.67% to be true to the theoretical probability, but of course the results of an experiment are not going to match the theory exactly every time. So we can see we're pretty close here, but a little bit off as we might expect. All right, I think that finishes the 6-sided die tab here. You will be trying this again in the practice exercise using the 10-sided die method. So let's go and do something kind of similar here for coins. So let's simulate 3 flips of the coin. And then we're going to list all the possible outcomes here in terms of number of heads that you could flip. We're going to calculate the theoretical probability and compare that to our simulation. So kind of a similar type example here. So I'm going to use a random number generator here again to generate either a heads or a tail. But instead of using the numbers here from 1 to 6, I want this to display either H for heads or T for tails. So what I can do here is I can embed a random between function into an if function. So the way this is going to work is I'm going to start with an if function. And for my first argument here, the first argument of a if function is your logical expression. So we want to check whether or not we're gonna generate a random number between 0 and 1. And if that number is equal to 0, so this is our very first argument here, is saying we're going to generate a number between 0 and 1. And if that value is equal to 0, I'm going to press comma after that to move to the next argument, which is value if true. So if that is true, if the random number that is generated is 0, I'm going to let that be h for heads. And then if I press comma, I'm going to be on the, if I click on the formula help here, I'm going to be on value if false. So if it's not heads, if it wasn't a 0, it must have been a 1. So if it's a 1, then I'm going to be putting a t there for tails, right? So altogether, this function says if the random number that we generate is 0, then output an h. And if the random number that we generate is not a 0, meaning it must have been a 1, then output a t. And if we press enter, we should get a random value, either an h or a t. In this case, it looks like we get an h. Let's scroll down to the bottom again and add 1,000 additional rows so that we have enough. Let's click on this cell, make sure we have A2 selected, and we're going to do 1,000 flips of the coin. So we're going to scroll down to, I guess this would have to be cell 1,001, right? Cell 1,001. So I'm going to hold down Shift, click on 1,001, hold down Control, and press Enter. And I can see here I do have a count of 1,000. I can also drag that one to the right. Oops, I messed that up. I'll drag that one to the right, and that's going to give me the second roll, rolling the die. The second flip of the coin is what we're doing here. We're flipping coins, and then we can do it one more to the right, and we'll have the third flip as well. So just like before, I'm going to copy these, and I'm going to paste these so that they don't automatically, recalculate. I'm going to paste the values only, and there you go. I have, I guess, 3,000 flips of a coin, but I guess you could call this 1,000 3-coin flips, right? And we want to count how many heads there are. So once again, we'll use the COUNTIF function, and we're going to count this range, A2, 3, C2, only if it contains an H. So we got to use quotes on that, and then close the parentheses, and that's going to count it if it's an H. There were 2 H's here, so it's going to give us a 2. There are 2 here as well. There is 1 there. We're going to accept the autofill, and that's going to give us the 1,000 outcomes for number of heads, right? So we know we could either, if we're going to flip 3 coins, we could have either 0 heads, we could have 1 head, or we could have 2 heads, or we could have 3 heads. And the way we can envision the theoretical probability is we could list out all of those possible outcomes. Now, I listed out all the outcomes here for the rolls of the die. We haven't really done that here. I'm going to show you that in another sheet here. So let me, where do I have this? I'm looking in my file here. So here's the Word document that kind of goes with this this file. And since we're flipping 3 coins and there's 2 outcomes in each coin flip, there are 2 to the 3 equals 8 different possible outcomes for the coins. And here they are, right? You could have 3 heads in a row. You could have 2 heads in the tail, head, tails, heads. So these are the different orderings you could have with the different the coin flips, right? So there are 8 different possible outcomes. One of those outcomes has 0 heads, which would be the 3 tails. 3 of those outcomes have 1 heads, either HTT, THT, or TTH. 3 outcomes have 2 heads, and 1 outcome has 3 heads. So we're going to use this kind of idea to fill in our theoretical probabilities here. Let's do this, actually, so we can kind of see these together. So in the theoretical probability here, I'm going to say, okay, there's 1 outcome that has 0 heads, and that's 1 out of the 8 outcomes that we have, and they're all equally likely since there's a 50-50 shot of getting either a heads or tails on a fair coin. To get 1 head, well, there are 3 outcomes with 1 head, so I'm going to type in 3 divided by 8, not divided by G2, divided by 8 there. Looks my numlock is off. There we go. 3 divided by 8. And then the 2, there are 3 outcomes with 2 heads, so that's going to be 3 divided by 8 again. And there's only 1 outcome with 3 heads, all 3 heads. So that's going to be 1 divided by 8. And those do all sum to 1, which tells us that, we really have accounted for every option. And now we want to compare those to the relative frequency. Let's first change those to percents. And we want to compare that to our simulation. So the relative frequency probability is going to be a COUNTIF function. And we want to count the number of heads. So I'm going to highlight this entire column here by doing Control-Shift down arrow to get to the bottom. Press F4 to make that an absolute reference. I'm going to press a comma, and I only want to count the values in there if they are a 0 in this case, or when I drag it down, it'll be a 1, a 2, or a 3. I'm going to close the parentheses, press Enter, and I'm going to accept the autofill. I have forgotten to divide by 1,000, so it's just giving me the number here. Let me modify this. I want to divide this by the 1,000 that we did, so I'm going to change that to divide by 1,000, and I'm going to drag that down, and it's going to convert those into the relative frequencies. Let's change that to percents. And now we can compare those to the theoretical probability. So we know that we should have about 12.5% of our 3-coin flip simulation should have heads 0 times, and we had 12.9%. We should only get 1 head 37.5% of the time. I got it 40% of the time, etc. Right? So you can see how I'm pretty darn close to the true theoretical probabilities. All right, we have 2 more tabs here, so let's go ahead to the Earth birthday. So this is to differentiate it from the Mars birthday. So we got the Earth birthday, we got the Mars birthday. I'm going to do the Earth birthday here, which is if you're living on Earth, there are 365 days in a year, and therefore 365 different birthdays. On Mars, there's like 600-something days, so you'll get to try that one later if you try the practice problem. Now this relates to what is called the birthday problem, which is something you may or may not be familiar with. The birthday problem says that if there are at least 23 people in a room, then there is a greater than 50% chance that at least 2 people share a birthday, right? So if there's 23 or more people in a room, there's a greater than 50% chance that at least 2 people share a birthday. And that's kind of counterintuitive for a lot of people. They're like, wow, only 23 people, and you're going to have a greater than 50% chance. Well, it is true, and if you're in my class, then we would have discussed this in class, but let me just kind of remind you of the process and the calculation here. The way we end up doing this is the way you can find the chance that at least 2 people share a birthday is you can use the complement rule. So you can say you can take 1 minus the complement of this event, and the complement of at least 2 people sharing a birthday would be no people sharing a birthday. And it turns out that this is a lot easier to calculate. So how do you find the chance that no people share a birthday? Well, if no people share a birthday, here I have the example with 5 people. Well, the first person can have any birthday out of the 365 days and still not share a birthday with anyone. He's the first person. He can have any birthday, right? The second person, if we want to still meet this criteria of not sharing a birthday, would have to have any of the 364 other remaining birthdays that wasn't the very first person's birthday. And the third person can have any of the 363 that were not the first 2 people's birthdays, etc., all the way down to, in this case, the 1, 2, 3, 4, 5th person, right? A general way to write the numerator here is the permutation of 365 choose 5, and a general way to write the denominator here would be 365 to the 5th power. Or if we generalize this, where n is the number of people in the room, this is 365pn, or 365 divided by n in the denominator, right? Or since that's the probability that 0 people share a birthday, if we want the chance that at least 2 people share a birthday, we got to take 1 minus that. So this is the general calculation that we would like to do in Google Sheets here. And then we're also going to set up a model here to generate random birthdays to actually be able to see these probabilities. So let's go ahead here, and we're going to code this for 85 different people. So first, let's type in 1 and 2 into the first 2 cells here, and let's drag this down through cell 85, or actually 86 to get 85. You'll see why I'm doing around 85 here in a second. And then we want to do that calculation here. So if we want the probability that someone shares a birthday, or at least 2 people share a birthday, we're going to take 1 and we're going to subtract the permutation, and you got to use the permute function. So permute, and it says this function takes an n and a k. The n is not the same n that I was using in that document here. The n is going to be the 365. What I mean by this is I was using n as the second value here, but the 365 is the value that goes out front. And the n is going to be the number of people in the room, right? So 365, and then the n, which they're calling k here, is the number of people in the room, which is 1. And that needs to be divided by, once again, if we look here, 365 to the n power. So 365 raised to the, so we can do the little shift 6 for the caret symbol there for the power, raised to the first power, right? And if I press enter, that's going to calculate the probability that if you have 1 person in a room, that he shares a birthday, at least 2 people share a birthday. Well, if there's only 1 person in the room, then he obviously doesn't share a birthday with anyone, right? Because there's only 1 person, so there's no possible sharing of birthdays. So the first one's going to be 0. But if we accept the autofill, let's also Control Shift down arrow here, and let's change these to percents. You will see that I've got the percent of people you'd expect to share, or not the percent of people, the percent chance that at least 2 people share a birthday based on the number of people in the room. So you can see here, as I mentioned earlier, once you hit 23 people, there is a greater than 50% chance that at least 2 people share a birthday. Once you get around 41, then 90%, and then once you get to 83, there's a 100% chance, rounded to 2 decimal places, that at least 2 people will share a birthday. So if you still don't believe me, let's do a simulation here to actually see that in practice by actually generating some random birthdays and comparing. Right. So let's copy and paste this column here. So I'm going to copy those values, Control Shift down arrow to get all of those, and paste this here. And then let's generate a random birthday in here based on the number of people. So basically what I want to do here in this column is I want to generate a number from 1 to 365 to represent that person's birthday. But I only want to generate a number if that number is less than or equal to the number of people here. So let's just put this as 23. And I want to basically create a model that will work in general, where I can modify the number of people here, and it will generate that many birthdays. And so the way we're going to do this is with an if function. So we're going to use an if function. And only if this value, the person number, only if this number is less than or equal to the number of people that we want to consider, do we want to generate a birthday. So I'm going to have to make the H2 an absolute reference, because I'm always going to want to reference that 23 people. So only if the person number is less than or equal to 23 do I want to generate a birthday. Well, I'm going to generate a birthday by using rand between 1 and 365. I should have noted here we are not considering leap years, so we're not, just for simplicity here, there is no 366. So no February 28th or 29th in here, right? If this value, the person number, is less than or equal to the number of people we would like to consider, then we're going to generate a birthday. And otherwise, we are going to just leave this as a blank string, which we can do by double quotes here. So I'm going to close the parentheses here, and that's going to generate a random birthday. There we go. And that has generated random birthdays for the first 23 people. If I change this number to, let's say, 10, then you can see I only have 10 birthdays. Or if I change it to 50, I've got 50 birthdays. And you'll notice every time that I change this, anytime I change anything, these birthdays will change. In this case, I'm going to let it stay that way, right? And actually, I'm going to insert I'm going to do that a little bit later. I'm going to insert a button a little bit later to allow us to kind of toggle when we would like those birthdays to recalculate, because we'd like to kind of see the result of many different simulations. I'm going to change this back to 23. Now, you can manually just kind of look through here and see if there are any matches, but that's kind of tedious and difficult to do. So instead of doing that, I'm going to use what is called conditional formatting to format any duplicate values. Now, if you're familiar with Excel, you will know that Excel has a default option to be able to highlight the duplicate values. But unfortunately, Google Sheets does not have a default way to do that, so we're going to have to do that by use of a formula. But just know, if you were to do this same thing in Excel, you could do this with a little bit less work. So the way we're going to do this is we want to highlight any duplicates in this column E. So if we have two numbers that are the same, we would like them to be highlighted so they're easy to see, rather than just kind of looking through this list to see if we have any two numbers that are the same. So I'm going to highlight E2 through E86. Because that's the total. We could go all the way up to 85, so I want to, just in case we have a bigger number, I want to consider all of those numbers. I'm going to go to Format, and I'm going to click on Conditional Formatting, and I am going to change the format cells if to a custom formula. Now, so here is where, if you're using Excel, there's an option right in here that just says duplicates. As of the time of recording, there's not an option for that in Google Sheets. So I'm going to go to Custom Formula Is. And the way we end up being able to do this is we can use a COUNTIF function. So if we type in COUNTIF and open parentheses here, unfortunately it doesn't give us kind of a nice option here to kind of like reference cells. So I'm going to just grab this range here, and I have to manually create this as an absolute reference. So I'm going to change this to an absolute reference here. And then I'm going to press a comma, and then I want to count this. I want to count if it matches, and I'm going to type in E2, which is the very first value, and I want to count if that is greater than 1. So let me go ahead and explain what this is doing, and you can kind of see here it has done it. It has noticed that the 170s are matching. So let me try to explain this formula, what this is doing. So it's saying look in this whole range of all the birthdays that we've generated, and then it says look for E2, right, and count if count the value in E2. Well, E2 is the very first birthday, or count how many times you see that value, right? So we only see that value once, so that would only come up as once. And then it's going to continue to do this formula for E3, E4, for every single value in here, right? And all of those values are going to result in a 1. It's going to result in a 1 if the value only happens one time. Well, if the value happens more than one time, then it's going to result in a 2 or a 3, or however many times that it happens, right? So we're going to count. If that value is greater than 1, we want to conditionally format that as a green cell, right? So basically, this is saying look at this entire column, and then if each of those values, not just E2, it's going to do this for each of these. If each of those values occurs more than one time, then highlight it, right? So now if I press done here, you can see that it's highlighting the 2 duplicates here. And if I was to just, I could type in 23 again. Actually, I guess I have to change it. If I type in 24, then it's gonna, change this, and I've got a new set, and it looks like I got another match here as well. Let's create a button here so that we can manually toggle the recalculation. So I'm gonna go to Insert, and I'm going to go to a checkbox here. And now, anytime that I select this checkbox, it is going to modify this. And I think if you look at my instructions, I might put this checkbox in cell G4, so I'm going to be consistent here. So now anytime I press this checkbox, I'm generating 24 birthdays. So let me go back to 23. And about 50% of the time, I should have something highlighted in green. So right now I've got, there was a matched birthday. I press it again. Oh, there were actually 2 matched birthdays in that data set. Click it again. Looks like there were no matched birthdays there, right? So now you can see that about 50% of the time, I'm going to have a matched number from 1 to 365, which is representing a birthday, right? So you can experiment with this. You can make this bigger. If I make this like 30, it's going to happen almost every time. Also note it's going to highlight all of these blank cells because they're blank and they match. But we're only worried about the first, however many cells. So that one matched. We had a match there. So you can kind of experiment with this and kind of see that it does match the approximately match the probabilities that we calculated over here. Okay, so we have one more tab here, which is going to be relatively short. So we have a number of students here, and what we would like to do is we would like to, maybe from the perspective of a student or of a teacher, we'd like to randomly select a student. So we would like to be able to toggle this box right here to randomly select a student. So we're going to do this by randomly selecting a number and then letting this cell return the name of that student. So the way we can do this is by using a VLOOKUP function in coordination with a random between function. So remember the VLOOKUP function, if we type that in here, the VLOOKUP function says, well, first of all, click on the value that you would like to basically find in another array. Instead of clicking on a value here, we are actually just going to type in ran between. And we're going to generate a random number between 1 and 30 because there are 30 people, right? And then if we go to if we press comma, we'll be on the next list, which is next argument, which is range. So I'm going to highlight this entire table for the range. So basically what this is saying is generate a random number from 1 to 30 and find that value in the first column of this table. Now the default is always going to be the first column, or actually VLOOKUP will always try to find that value in the first column. And then if we go out of this, and we press a comma, we're going to be on the index argument, and the index argument is asking us which column would you like to return, and I want to return the second column, which is the name, right? So altogether here it's saying generate a random number from 1 to 30 and find that number in this table, and then give me back the corresponding value in the second table. So if the random number that it generated was a 4, then it would return back Aaron Simmons. Or if the random number was 10, it would return Tony Alexander. So I'm going to go ahead and press enter, and it's going to give me a random person. Looks like I got Christopher Ferguson. Where is that person here? So it must have been a random number of 24. And just like before, I'm going to insert a checkbox here. So let's insert a checkbox so that I can just click that, and anytime I click that, that is going to change the random name. So kind of a cool little thing here. You could use this for anything. If you wanted to, you had 10 different restaurants you're considering going to go out to dinner. You could use this to do that. Every day you're going to go to a random place, so you're going to click your checkbox. It's going to tell you which place to go to. Or if you have a huge data set and you want to randomly sample from that and you want to grab one, you could do something like this as well. All right, I think that is just about all I wanted to discuss in this video related to Google Sheets Lab 4. So hopefully you found this helpful.